Hello, my amazing students. This is Mrs. A, and I am here to help you a little bit with 3.4 in college algebra, and we are doing rational equations and radical equations in 3.4. And the first one that I wanted to show you was this one right here. This is number 10 in our book. And it's showing a proportion actually because it's a fraction that's equal to a fraction. And remember that rational expressions or rational equations have a variable in the denominator. So they're not just polynomial expressions. They don't act like polynomial expressions. So what we're going to do when we're when we're trying to solve a rational equation is we're going to multiply through by the least common denominator. And notice what's going to happen when we do that. We always have to remember that our domain of the function is taken before we do that. So our domain of our function, we're going to have a w minus 7 in the denominator. So if that went to 0, we'd have a 0 in the denominator, and that would be bad. So we're going to take a note and say w cannot be equal to 7 because then the denominator would go to 0. Okay, so once we make that note, we can multiply both sides by w minus 7. And when we do that, we're left with 49 is equal to w squared. Okay, so when we look at that, we say, okay, we're solving this. We're going to use our square root property. And we're going to say the square root of w squared is equal to the square root of 49 plus or minus. Remember, when we're using our square root property, we always put a plus and minus on one side. And this is going to give us a plus or minus 7 is w. But we remember and we take note that, I already took the domain. The domain said that positive 7 was a no-no. So I'm only going to have a negative 7 for my solution. So w is negative 7 in this one, and that is correct. Okay, so there's the screen a little bit if you want to see it a little bit better. Problem 10 on rational expressions, 3.4. Okay, so now we're going to get the next problem out. And this one is a little bit more complicated. We're going to factor every denominator. So we're going to pull out a 3, and we have an x plus a 2. We're going to pull out, this one is an x plus 2, x minus 2. And then the last one is just x minus 2. So I'm going to look and say, okay, what is my LCD? And my LCD has got to have a 3, and it's got to have an x plus 2. And it's got to have an x plus 2, but it already does, and they can share. It's got to have an x minus 2 to make this guy happy. And then x minus 2 is already in there. So my least common denominator is going to be 3 times x plus 2, x minus 2. So now what I'm going to do is I'm going to multiply both sides by this least common denominator. Okay, now what's going to happen here, and I didn't leave myself much room to write that, did I? So we're going to multiply all the way across the top. So I'm going to go ahead, just because of space, and I'm going to multiply this one by 3 times x plus 2, x minus 2. So 3 times x plus 2, x minus 2. And what's going to happen there? My x plus 2 on the bottom and my x plus 2 on the top is going to cancel. My 3's are going to cancel, and I'm just going to be left with an x minus 2. So x minus 2 is going to go down here, and this and this and this and this cancels. And remember that these were the same thing as that. So the only thing I have left on the first term is an x minus 2. So then I move to the next term. Okay, and this term right here is the one that I'm talking about. So I'm going to multiply the numerator by this whole thing. Now I've got a problem here. I've got a minus sign here. So when and again, I'm just doing this because I left myself no room to write this And I'm trying to make it so that you can see it and understand it. Okay, so now when I put this on the numerator, since there was only a 1 before, notice that this cancels, this cancels, this cancels, this cancels, and I'm left only with a -3. Okay, and then we're going to do the same thing on the end, but we have a little bit more room there. So we're going to multiply this one by 3 times x plus 2 times x minus 2. And what do we have now? So our x minus 2 is going to cancel our x minus 2, and we're left with 9 times x plus 2. Okay, so we have taken this least common denominator and we multiplied it to the first term and to the second term and to the third term, and this should be what we have left. Okay, so now on the left I have x minus 5, and on the right I have 9x plus 18. Okay, so I'm gonna, oops, I lost an x there, 9x plus 18. And then I'm going to get all my x's on one side, so I'm just going to take this x over here. So this one's going to be an 8x now. And then I'm going to subtract the 18 from both sides. So now this one is -23. And so my final answer for x is I'm going to divide both sides by 8, and I get x equals -23 over 8. And that is the correct answer. Okay, notice that -23 over 8 does not make any part of the least common denominator go to 0. So that is that screen a little closer up there. And I need to remember to leave a little bit more room on the left when I write these problems here. Okay, so the next one. Okay, so this one is the next one here. This is problem number 26 in our book. All right, so what we're going to do is first factor all of our denominators because we don't know what we've got. Notice that we do have an x cubed plus 27. And remember that if we have a plus b, a cubed plus b cubed, that's going to factor as a plus b times a squared minus ab plus b squared. Okay, that is our sum of two cubes formula. And that's what we have down here is a sum of two cubes. 27 is a perfect cube, so we have x cubed plus 3 cubed. So let's factor that first. So we've got x cubed plus 3 cubed is x plus 3. And then this first term squared, this product opposite sign, and the last term squared. All right, so now does anything look familiar? Notice that this little weird thing over here, x squared minus 3x plus 9, is the denominator of this first term. And our x plus 3 is the denominator of our second term. And our complete x cubed plus 27, which is what all of this multiplied together equals, is the denominator in our third term. So we're going to just go ahead and make this right here our least common denominator, which is the same thing as x cubed plus 3 cubed in its factored form. Okay, so this is our LCD. So now we're going to multiply everything all the way across by this LCD. So what I'm going to do here is I'm going to write my x plus 3, and I'm going to write my x squared minus 3x plus 9 right below it. Okay, because everything is going to be one or the other of those factors. She's asleep, honey.
Oh, she is?
Yes. Okay, so there we go. There's my 18. I didn't want to lose it. So now this one and this one are going to cancel. And I'm going to be left with x plus 3 times the 18. So this one cancels this one right here. But this one's going to go all the way across. So I'm not going to cancel it right now. And then 18 times x plus 3. So that's our first term. So then we move to the second term. And on this term, my LCD is going to just cancel the x plus 3. And it's going to leave this trinomial times a negative x. So we're going to have negative x times the trinomial x squared minus 3x plus 9. Okay, and then lastly, the third term, the denominator x cubed plus 27 is the same as the factored form of the same denominator. Therefore, this is going to cancel the denominator here, and I'm just left with an 81. Okay, so that's what I have so far. Okay, so now we're going to simplify. We've got an 18x plus 3 times 8 is 24. So that's going to be a 54. Okay, so now my minus x is going to distribute all the way through here. So I got a minus x squared, and a minus times a minus is a plus 3x squared. Excuse me, that first one was an x cubed, wasn't it? Okay, and so plus a 3x squared minus a 9x. All right, now this is cubic. So I'm going to go ahead and move my 81 over here to the left, because everything's going to have to be set equal to 0 over here on the right. So this is what I have. And over here it's set equal to 0. Okay, so now I'm going to need to get everything in descending order of the variable and see what I have. So my x cubed term, I have a negative x cubed. It's going to go on the front. I have an x squared term, which is going to be plus 3x squared. Okay, so I've taken care of this one and this one. And then I have a negative 9x and a positive 18x. So that's going to be a positive 9x when I put those two together. So that's going to take care of that one and that one. And then I've got a 54 minus an 81. Okay, so 81 minus 54 is going to be a 7 and a 2, a 27. And that's going to be a negative 27. Okay, so now see what I have there. Now I am going to solve this one by factoring by grouping. And on the denominator, if you look, I've got a... If I take a let's pull a negative out of that, a negative x squared. So I'm going to pull out a negative x squared here. And I'm going to end up with an x minus 3. Okay, and then in the next one, I'm going to pull out a 9. And I'm going to be left with an x minus 3. All right. So pulling up another board here, a little bit cleaner board. I'm going to let you see that one, so I can pull up a little bit cleaner board. So get all those notes off of there. Okay, so that's what I have that I had down at the bottom of the other board, and now it's a little bit cleaner looking because I'm able to spread it out a little bit. So now I'm going to factor my x minus 3 to the front, and I'm left with 9 take away x squared. And the two factors together multiply to give me a 0. So I factored by grouping. Okay, so now to solve, I'm going to take each one of the factors and set them equal to 0. So I get x minus 3 is equal to 0. And then this one really can factor again. And this is going to give me a 3 minus x and a 3 plus x. Both I can set equal to 0. Okay, so remember, I have a cubic equation, right? Back over here on this board, we have a cubic equation right there, x cubed. Negative x cubed means it's cubic, which means it should have 3 solutions, or the possibility of 3 solutions. So here we go, back here, and we set this one equal to 0, and we get a 3. We set this one equal to 0, and we get a 3. And we set this one equal to 0, and we get a negative 3. Okay, but when we go back to our original, a negative 3 would have made our original equation go to 0, which also makes our least common denominator go to 0. Therefore, a negative 3 is a no-no. Okay, so we're going to cross off the negative 3. Now, I'm doing this video after we've already talked about equations having repeated roots. So we have x is equal to 3 in there twice, therefore that would be a repeated root. And we've talked about how a graph of a function is going to pop the x-axis when we have a repeated root. It will not go through it, it will pop it. So there is the end of that very lengthy problem. So here was the first board once again on this problem. And this was problem number 26. And here is the finish up board on problem number 26. And now we're ready to go on to some radical equations. All right, so here we are with number 49, and we're going to end up isolating the radical, squaring both sides, and this one should not have another radical left, but sometimes we have 2 radicals and we have to go through the process twice. All right, we always have to check our solutions because remember, I said that if we had something that is obviously not true, negative 5 does not equal 5. However, when you square both sides, then all of a sudden something that was not true becomes true. And 25 is equal to 25. It is because of that we must always check our answers, because we can take something that is not true and turn it into a true statement, and we have to go back to the original equation and make sure that it is true in there. Okay, so here is our cool problem that we're going to do. The first thing we're going to do is isolate our radical, which means we're going to add a 3 and add a 3. So now we have the square root of 2x plus 1 is equal to 6. And that's pretty clean. So now remember, when we square both sides, we're squaring both whole sides. So we're going to take this one, square it, take this one, square it, and then the square of the radical just leaves me 2x plus 1, and the square of the 6 leaves me with the 36. So now I'm just going to solve this one linearly because it's a linear equation. So we are going to have 2x, we're going to subtract 1 and subtract 1, and we get 35. So we're going to get x is equal to 35 over 2. Now we've got to check that back into the original equation. So I've got twice 35 over 2. So twice 35 over 2 will give me 35, plus 1 is 36. The square root of 36 is 6. 6 take away 3 is 3, and that is a good solution. So that was a pretty easy problem. All right, so now let's look at another one. This is problem number 65. This is one that we're going to have to square twice. Okay, so we're going to isolate one radical. by getting the other radical on the other side. So we're just going to subtract the square root of x plus 2 and subtract the square root of x plus 2. Just to get one by itself. So we've got this one by itself. So the square root of x minus 3 equals 5 minus the square root of x plus 2. Okay, so now we're going to square both whole sides. And this is where a lot of students make their error. They square pieces and parts, and we cannot square pieces and parts. We must square whole sides. Okay, so this one squared is going to leave an x minus 3. And then over here, we're going to have the first term squared, which is 25. And this product, which is a negative 5 onto the radical, it's going to be doubled. So it's going to be a negative 10 onto the radical, x plus 2. And then the last term squared is going to also square out that negative sign because it's this times itself. So we're going to end up with a positive x plus 2. Okay, so that's what we have now. And we're going to now get this remaining radical by itself. So on the right-hand side, I've got a 25, and all the way over here, I've got a 2. So I've got a 27 altogether. So I'm going to subtract a 27 from that side and subtract a 27 from this side and clean it up a little bit. So now I've got an x minus 30 on the left. And on the right, since I took away the 27, I still have an x. So I'm going to have an x minus 10, the square root of x plus 2. But since I have an x and an x, can't I just take those two x's away? All right, so we're going to do that. We're going to take the two x's away. There it goes. There it goes. We took away the two x's, just canceled them out. And so now I have this radical. And can I just divide both sides by a negative 10? So I'm going to divide this by a negative 10 all the way across. I'm going to divide this by a negative 10. Okay, so now I'm going to get a new board and simplify that. And that is going to be, on the left, it's going to be a 3. And on the right, it's going to be just the square root of x plus 2. Okay, so that's the first board. And now we have things much more simplified here. Okay, so this is our new equation. And now we're going to square both sides again. And when we square the square root, we get an x plus 2. And when we square the 3, we get a 9. And we take the 2 away, and we take the 2 away, and we get x is equal to 7. Okay, and this one was number 65, and the answer to number 65 is 7. So we did get it right. But remember, I can't be sure, other than my answer key, right? I can't be sure that I have this answer right until I go back into the original equation and substitute it in to see if it is indeed a solution. Okay, so we're going to not take the time to do that, but I want you to do that because it's necessary. You don't have the answer key, and you need to take it back into the original equation and plug it in, and it does work. Okay, so that one was problem number 65, and I'll be back with more. All right, we are back with number 76, which is going to be the last of the radical equations that we work, and then we're going to work on some formula equations there. All right, so on this one, we're going to, since we already have one side isolated, we're going to go ahead and square both sides. So we will square the left and square the whole right side. Always whole sides. So now the square of the square root gives me a 6x plus 6 on the left. And on the right, I get the first term squared, which is a 25. And then this product doubled is going to give me a 10 times the square root of 21 minus 4x. And then the last one squared, I'm just going to have to write it down here, is going to be 21 minus 4x. Okay, it comes out of the radical. So now we're going to take this whole thing and try to clean it up. And while we're cleaning it up, we're going to try to get this radical by itself. Now on the right-hand side, I've got a 25 and a 21, which I'm going to add together and get a 46. So then I'm going to subtract a 46 from this side and subtract a 46 from this side. So now I have a 6x minus a 40. And on the other side, my 25 and my 21 and my 46 all canceled out. And I have a negative 4x. And then I've got a positive 10 square root of 21 minus 4x. Okay? So there's what I have now. And now I'm trying to get this by itself. So I'm going to add a 4x and add a 4x over here. Okay? So now I'm going to get a 10x minus 40 on the left. And on the right, now I just have a 10 square root of 21 minus 4x. Okay, so there we have it. Okay, so there's your whole equation. And I'm going to get another board and continue. All right, so if you look at this, we have, before we go on, we have a 10 and a negative 40 and a 10. Can I just divide the whole thing by 10 as I'm cleaning it up to get rid of all those 10s? Well, that's what I'm going to do, okay? So I'm going to end up with x minus 4 is square root of 21 minus 4x. Okay, so I just cleaned out the 10s, divided everything by 10, and now we're going to square it again. So we square the right, and we square the left. Okay, so when we square the left, we're going to get x squared. This product doubled is negative 8x. And then the last one squared is positive 16 is equal to 21 minus 4x because the square takes care of the square root. All right, so now we do have a quadratic equation. So don't we want to get everything on one side and a 0 on the other? So we're going to minus a 21 and minus a 21. We're going to add a 4x and add a 4x. So now this is gone, and I get my 0 on the right. On the left, I get x squared minus 4x minus 5. Okay, well, I know that this factors x minus 5, x plus 1 gives me my negative 4x in the middle is 0. So I end up with x is 5 and x is negative 1. Now I have to check. Okay, when I go back to my original equation, which was way over here. So my original equation is this right here without the squares. So we'll take the squares back off. And we're going to plug in an x is negative 1. Okay, if I plug in a negative 1 here, then I'm going to get a negative 1 times a 6 is a negative 6 plus a 6 is a 0, and the square root is a 0. On the right, I get a 5, and then 21 minus, and we're plugging in a negative 1, so that's going to become a plus 4. 21 plus 4 is 5. So we're going to get, 21 plus 4 is 25, but the square root is 5. So we get 5 plus 5 is 10. And 10 is not equal to 0. Okay, so our first answer, negative 1, does not work. But when we plug in the other answer, we plug in the 5. And that's going to give us a 36, and the square root of 36 is 6. We plug a 5 in here, we get 21, take away 20, which is 1. The square root of 1 is 1. 5 plus 1 is 6. 6 equals 6. And that one works. Okay, so that was our first board on this one. And here was our second board. And now we know that this one has to be crossed out. We have to cross out the x minus 1, and we would circle our good solution. And that is the last radical equation that we're going to work. So now we're going to pick a couple of formulas to solve, and we will be done. All right, students, so now what we're going to do is we're going to solve this formula, and we're going to solve it for t. Okay, so we're going to try to keep t in mind there. We're trying to get t by itself. Notice t is in the denominator. So we're going to multiply through by the least common denominator, which is ABT. So, or TAB, it doesn't matter. We're going to multiply the whole thing through by TAB. So when I multiply this one by TAB, and this one by TAB, and this one by TAB, then what happens? My T's cancel, and I'm left with an AB. My A's cancel, and I'm left with a TB. And lastly, my B's cancel, and I'm left with a TA. All right, we're trying to solve again for T. And so I've already got my T's on the same side together. So I'm going to factor the T out and get a B plus A. And on the other side, I have an AB. So now trying to get the T by itself, I'm going to divide by B plus A. And over here, I'm going to divide by B plus A. So now, don't I have T all by itself? So T is equal to A over B, AB divided by B plus A. And that should be our correct solution. And it is, because I have the answer key. So that is problem number 86 in your book. And it's dealing with a formula. Okay, so we're going to do one more formula. All right, so here's our last problem for 3.4. Yay! So we're solving for H. Okay, so we're going to keep H in mind here. Now, when we're solving a formula for H, we're going to get everything else on the other side and only the H by itself. Now, H is, this is a proportion, so I could cross multiply to get my H on the top, or I can multiply by the least common denominator. They're really equivalent. Okay, so I'm going to multiply just by cross multiplying this time. So when I cross multiply, I'm going to get B squared times R plus H. And on the other side, I'm going to get 2G R squared. Okay, so now I'm going to try to get H by itself. There is no H over here, so we're going to get V squared R plus V squared H is 2G R squared. Okay, so now this is the one I'm trying to get by itself. So let's get that term by itself. And we're going to get this one over here on the other side. So we're going to subtract it from both sides. So now I'm going to put the V squared H out front. And then on the other side, I'm going to have 2G R squared minus, so I'm minusing this one right here, V squared R. Okay, so now what is my last step going to be? Since I have no H over here, and I just have a V squared with my H over here, can I not just divide both sides by V squared? Okay, so my final answer, and I'm going to squeeze because I don't want to get a new board for this, is V squared on the bottom. Okay, so 2G R squared minus V squared R over V squared. So I didn't want to rewrite it because it's really pretty late and I'm tired and I'm going to go to bed. And this is Mrs. A, and may God bless your day.